we said that pH is equal to 1/2 pKa 1 plus pKa 2, or it could be 1/2 pKa 2 plus pKa 3. Then at the last endpoint, we have to use a different formula. And then at the beginning point, we got to use a different calculation. Okay, so remember at the starting point, we can use Ka and do an equilibrium calculation to figure out that pH. And then at this endpoint here, at the last endpoint, we can use Kb to figure out the pH at that last endpoint. So, using this titration curve, we can figure out something more about how to use these substances. So, for example, in this region here, what is that called? Yeah, that's the buffer region. So note that we can use this acid and its conjugate base to make a buffer in this region, and also in this region, and also in this region here. Note that a buffer has a buffer capacity, so if too much base is added, then the pH will shoot up because that buffer has exceeded its buffer capacity. If too much acid is added, then it can go, pH goes down. And the other thing you can do here, again, this is all about you being scientists and engineers controlling something. You can control the charge on a substance by adjusting the pH. And by controlling the charge, you can do, for example, an electrophoresis experiment and separate, say, one protein from another protein based on charge. Okay, so there's the first 10 weeks of Chem1B in 20 minutes. So maybe we should just done this in the first class period, and you're gonna get your 5 units of credit for it. Right, so I guess we're about 60% through the semester, so you've gotten 3 out of the 5 units out of this. Okay, so before we go on and talk about thermodynamics, do we need to review the quiz that you took before spring break?
Yes.
Love it.
So, do you control the charge of the substance by the pH? Does your body do that?
Yeah.
Is that what your body does?
Yeah.
Like, is that how your brain fires the neurons?
I'm not quite sure what's happening between those nerve endings for that kind of process, because I know there's neurotransmitters and things like that. But for example, we know that we looked at the pH of blood, and how we have those two blood buffers, the baking soda CO2 and then the hemoglobin blood buffers. And we said that based on that, we can figure out what the charge is of the acid and conjugate base in each case. But yeah, basically that's what our body is doing. So we know that, for example, in your cells, the pH of the fluid in our cells is a certain pH. And that's going to determine what the charge of those different ions or different sugars or different proteins or amino acids is going to be. Okay, so let's talk about question 1. The CO2 bicarbonate buffer is one of the 2 main buffers in our body. So there's an equation which represents the equilibrium. So when a person hyperventilates, the person exhales CO2. So note that when CO2 is being exhaled, here's CO2 as a reactant. So is CO2 being added or is CO2 being removed from this reaction when a person exhales CO2? Yeah, so CO2 is being removed that means that this reaction is going to shift toward the toward the left or toward the reactant side. So as the reaction shifts toward the reactant side, what happens to the H plus concentration? Does it increase or decrease? It decreases, and as it decreases, that means the blood pH is going to increase. Okay, so again, as the H plus concentration decreases or drops, the pH is going to rise. Okay, so note that there is that inverse relationship between pH and the H plus concentration. Part B. Why does breathing into a paper bag help a person who's hyperventilating? Yeah, so what's happening is when a person breathes into a paper bag, okay, so here's that person again. Here's the paper bag. So when a person exhales, they're exhaling the CO2, but by breathing into a paper bag, yeah, they're actually going to rebreathe in the CO2. So that means that as the CO2 is inhaled, what happens to the CO2? Are you adding or removing CO2? Yes, you're adding CO2, and that's going to shift the equilibrium toward the product side, which means that the H plus concentration is going to increase, which means the pH is going to drop back down to where it's supposed to be. Okay, so I think the term for hyperventilation is called respiratory alkalosis. Have you heard that before? No? Okay, then. Any questions on question 1? Does anyone drink Coca-Cola? Is that the exclusive soda drink that you drink?
Monster.
No, I'm just asking because I'm wondering if the name brand is important in what you drink or what you use. Because really, when you guys are professionals and say you're looking for jobs, you often, what a lot of branding is the popular term now. You want to give yourself or make yourself a brand. See, if you can make yourself a brand like Coca-Cola as a brand name, boy, you'd be not only very popular, you can make a lot of money for yourself. So note that Coca-Cola is such a popular brand that, boy, I can't see any soda ever overtaking Coca-Cola, whether you like Coca-Cola or not, because of that brand. So if you can brand yourself, boy, you can probably make your children and grandchildren and great-great-grandchildren rich for the rest of their life. Okay. Yeah, because I thought one of the students in organic chemistry, she says that her parents own a gas station with a convenience store. She says that there's a lot of customers who go in. They always skip the generic brands, so they always go right to the Coke. And the Coca-Cola costs, like she said, like $2 to a bottle. The generic is $1.25. Note that they're paying a lot more just for the brand, just for the name, as opposed to the soda. Rolando.
Aren't they paying for the chemical formula too? They're paying for the specific taste.
Yeah, that's what they claim. That's why Coca-Cola claims they got a secret formula. Of course, they're never going to tell you what that formula is. But who knows? Does it really taste any different than, I don't know, than the Safeway brand of soda or Or is it different than any other soda? I mean, I know a lot of people claim it is. But if you were to do a blind taste test of, say, 5 different sodas, would you be able to tell which one is Coca-Cola, which one is Pepsi, which one is...
Oh, yeah.
I've seen that.
And the smell of it too. It smells different.
Sounds like a test.
Yeah, so if you take that challenge and because there's a lot of people who say that I can tell the difference between Coke or Pepsi or whatever. They take that test and they can't tell. Right? Actually, even in wine, there's expensive wines and cheap wines. And they say that they take these wine tastings and they say that the $5 bottle of wine tastes better than the $50 bottle of wine. Omar.
Didn't Coca-Cola used to have like cocaine?
Yeah.
So, like, would you be able to taste the difference back in the day? So,
I'm sure you feel the difference.
when did they stop making cocaine?
Well, Coca-Cola's been around, I think, since the 1800s. So it's probably early in the 1900s they stopped putting cocaine in.
It was made by pharmacists, so they used to put a bunch of different drugs into soda pops. And that's why I saw this like random thing where they were investigating that, who came up with Coca-Cola, because it was between these 2 different pharmacists.
Oh, really?
They kind of came up with the same thing, and they were investigating whether or not you could tell the difference between the chemicals and something. Well, supposedly you could. I could taste the difference. But whether or not you have a generic soda that tastes good and Coca-Cola, you can tell the difference between whether or not it's Coca-Cola, but if it tastes better to you, it tastes better to you.
See, a lot of it's psychological because if you look at the name before, you have this emotional experience with the soda. It tasted so good that first time. Then every other time you drink it, it's going to taste as good. You have this image or this memory of how good it tastes. So then every time you taste, it's going to. That's why a lot of these things it's like an addiction. It tastes good, you expect it to taste good. If it doesn't taste good, you got to drink more. Because I shouldn't say this on film, but I had this friend when I was in graduate school. He smoked, this thing. He said he felt really, really good. And he said he had to keep on smoking because he was never able to feel as good every subsequent time he smoked. So that's why he got addicted to this thing. And he sort of kept on smoking because he wanted to reach that level or that feeling he had the initial time he took it, and he never was able to get to that place again. So that's why people get addicted to these things, because they can never get to that place again. So anyway, what were you talking about anyway? Oh yeah, good question too. Okay, so phosphoric acid is a substance that gives Coca-Cola its tart taste. So let's see. Now phosphoric acid, is a triprotic acid. So let's take a look at the. Okay, so for this one, we have to look at the dissociation of phosphoric acid. So here we have phosphoric acid. Okay, so we can look up the pKa of each acid. Okay, so let's see. So look, find I have the pKa here somewhere.
Excuse me, quick question. Did he graduate?
He's a doctor now. Let's see, I have this, let's see, I thought I wrote it down. Okay, I guess we'll have to do some calculations. Let's take a look at table 16 point,
PK.
yeah, so let's take a look at the KAs, and then calculate pKa. So table 16 point, table 16.4 on page 563 gives the Ka. So the Ka for H3PO4 is 7.5 times 10 to the minus 3. And then for H2PO4 minus, it's, let's see, 6.2 times 10 to the minus 8. And for HPO4 2 minus is 4.8 times 10 to the minus 13. So based on those Ka values, we can calculate pKa. Yeah, so let's do that calculation.